Today we're going to be looking at Gemini Diffusion, which is a very interesting release from Google because this is the first diffusion-based text generation model from a frontier lab. Now, don't expect any record-breaking performance, but the speed of generation of this model is incredibly fast. You actually have to slow it down in order to see what it does. Here is a real-time example. This is the true speed of generation of the model. It generated a game which works, and it generated 800 tokens per second, which is pretty incredible. But keep in mind, it's not a state-of-the-art model. In fact, the Gemini team is comparing it with Gemini 2.0 Flashlight, which is a relatively small model, but this model seems to be even smaller and has comparable performance. And one more thing, Google is not the first one to create a diffusion-based LLM. There is a company called Inception Labs who released Mercury, which was one of the first commercially available diffusion-based large language model. Even Andre Karpathy at the time tweeted about this. We're going to come back to this tweet. Google is calling this an experimental release, which is available in early access. Diffusion-based text generation model gives users greater control, creativity, and speed in text generation. And as a user, you should expect rapid responses, more coherent text, because it's going to be generating everything in parallel. I'll show you how it works. And you can iteratively refine the generations. And it does a really good job at relatively simple prompts. Now, just to test it out, here is one of my prompts to create a web page. And the speed of generation, again, is pretty incredible. It feels like you're running this on Grok hardware. So we generated at 800 tokens per second. You also get a preview of the web page, which is pretty neat. It does struggle at more complex tasks, but I think it opens up the possibility of new paradigm in text generation models. Now, in order to understand the importance of diffusion LLM, we need to understand how the current LLMs work. So here's a very simplified representation of an auto-regressive LLM. The idea is that based on the distribution of the input text or the text that it has generated so far, it's going to predict the next word. So let's say this is the input text. It's going to look at the probability distribution of the next token that it can generate, and it will sequentially generate a new token in each step. Now, there are two main issues. The first is, since it's sequentially generating text, it's going to be very slow. And the second is, in the sequential text generation, if it makes a mistake, it cannot go back. And we're talking about these non-reasoning models. Reasoning models can generate parallel traces. So there is a better probability of refining its mistakes. Now, diffusion, on the other hand, works in a very different way. I'm going to show you the text generation process, but in order to understand diffusion in general, here is how it works. We're going to look at an image generation example. Later, I'll show you how text generation works as well. So in image generation example, you take your training data, you add different level of noises, and the goal is that the model is going to start with this white noise from the beginning and regenerate your original image. Now, in case of diffusion, you're going to have a fixed size image or frame, and all of the pixels are generated in parallel. And all of them need to preserve the spatial coherence of the image or frame. Now, for the text generation, the diffusion models will create a fixed context window. Now, not all of them or all of the generation are going to be exactly the same size, so there are a lot of masked tokens. But in parallel, it can generate different iterations and then correct those, because it has to generate this whole window of text at once. So here is a video of text generation from the Inception Lab. This is the Mercury model, but you can actually see that the model is generating all of the tokens in parallel. And if it realizes it has made a mistake, it only fixes that specific part of the generation, and it keeps the rest of the tokens. Now, the beauty of this process is that since all of the text or all of the tokens that are generated at once, it can easily figure out its mistakes and correct them in the next iteration. Theoretically, you're going to have a lot more control on the generation, but it's extremely hard to train diffusion-based LLMs. And seems like Google has cracked the code with these smaller models. So let's quickly look at a few examples. Now, keep in mind, this is a research preview and we don't know a lot of details. For example, what is the context window of Gemini Diffusion? What are the number of parameters and so on and so forth. If we look at some of their examples, it can generate drawing apps very quickly. For example, I can change the color as well, right? This seems to be working. I also saw a few more examples. So for example, if we look at a tic-tac-toe example, it's able to generate this game as well. And in my experience, for simple prompts, it does seem to work fine. Okay, here's an example of k-mean clustering algorithm. This is a machine learning algorithm. So let's say we increase k, we can run the clustering algorithm, and you can see as is able to create this animation of the k-mean clustering algorithm. But for more complex prompts like generating 20 bouncing balls within a spinning heptagon, I think it will struggle. We looked at an example earlier. In this case, it's not actually adding the balls and the heptagon is not spinning. But again, speed of generation is really great. So don't expect a lot from this first iteration, but I think it opens up different possibilities. You can provide a whole bunch of text and ask it for instant edits. And now it's looking at the whole text in one shot and it can make those changes rather than sequentially generating different tokens for you, just like an auto-regressive model, right? So this is really neat that if you have existing text or code and you want to make changes inside that code, I think a model like this is going to be really helpful. As an example, here is adding comments to the code. So rather than regenerating this whole code, it can directly include comments. So I'll highly recommend to test this out. Apply for the waitlist. We're going to end this video on this post from Andre Karpathy, which he posted when the Mercury diffusion-based LLM was released, but I think it still applies. So he says, most of the LLMs you have been seeing are clones as far as the core modeling approach goes. They are all trained auto-regressively, that is, predicting tokens from left to right. Diffusion is different. It does not go left to right, but all at once. You start with noise and gradually denoise into token stream, as we saw with those couple of examples. Most of the images/video generation AI tools actually works this way, and they use diffusion, not auto-regression. It's only text and sometimes audio that have resisted. So it's been a bit of a mystery to me and many others why. For some reason, text prefers auto-regression, but images or videos prefer diffusion. This turns out to be a fairly deep rabbit hole that has to do with the distribution of information and noise in our own perception of them in these specific domains. If you look close enough, a lot of interesting connections emerge between the two as well. All of that is to say, this model has the potential to be different and possibly showcase new, unique psychology and new strengths and weaknesses. I encourage people to try it out. And I'll say exactly the same about Gemini Diffusion. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.